Welcome everyone to Night Sky Mythbusters, the Lunar Edition. Your presenter tonight is John Pannuto. He joined the Oakland Astronomy Club 3 short years ago, but he quickly learned that the view through a telescope is only the first part of enjoying the night sky. And he's going to show you that understanding just a little bit of what you're observing makes the hobby even more enjoyable. So we're going to be having a very enjoyable talk here for half an hour, and we encourage you to insert questions in the chat. Now you got to log into YouTube, but over on the right, the live chat, just go ahead and type stuff. We're going to have some good questions here, I'm sure. And at the end, John's going to get to them and to answer as many as time permits. So please chat those questions. And so without further ado, I'm going to throw it to John.
Thank you very much, Brian, and I appreciate your being with me tonight. Also, another fellow from the club, Rick Atkins, is going to help in the chat window as well. So go ahead and pepper them with your questions. Well, I'm so glad that you're able to be with us tonight because I really do enjoy the moon, and I hope that I can share some of my enthusiasm with you. So our goals tonight are really pretty brief. We're going to consider a few common misconceptions about our nearest neighbor, the moon, shed a little light on why things are the way they are, and lastly, share some beautiful images of the moon. The final slide will include a list of cool websites and other resources that we've referenced. So sit back and enjoy the show. Lunar misconceptions. Some can be dispelled by common sense, but sometimes even what looks to be commonsensically true turns out to be incorrect. So lunar common sense needs to be tested by facts and observation. A great example of a lunar sensation leading us to a wrong conclusion is the apparent motion of the moon. To show you what I mean by this apparent motion, I'll use a freely available planetarium software called Stellarium, which you can see on your screen now. This planetarium screen represents tonight's sky. I've preset it for 10 o'clock tonight. The view is looking south, and you can see to your left is the east, and to your right is the west. I'd like you to watch the moon as I slowly move time forward just a few minutes. You can see, even just over the course of a few minutes, that the moon appears to move from left to right, towards the west. So this is the apparent motion of the moon. The reason for this sensation is that the Earth is turning on its axis rather quickly, from right to left, making the less speedy objects in the sky, like the moon, seem to move in the opposite direction. Well, taken alone, this familiar apparent motion might lead us to conclude that the moon orbits the Earth from east to west. But what would the orbital motion of the moon look like if we could eliminate the Earth's rotation? Let's try that. We could observe the moon's location tonight at 10 o'clock and then come back tomorrow night at 10 o'clock and note the moon's location again and do this for a few nights in a row. We know the moon is orbiting, so we know its location is going to change from night to night, but which direction is the change? Is it farther to the right or to the left? We'll use the planetarium software to speed the process up, so let me make sure that we're set. Yep, we're set fine for just about 10 o'clock tonight. And I'm going to move us ahead 24 hours very quickly, just with a push of a button. First, I'm going to mark a star for us, this guy here, Fomalhaut, so you have something to compare the sky and the motion of the moon against. But watch what happens. Here's 24 hours later. And you can see the direction of the moon is definitely not going the direction that we thought it was going to go. Now, I've taken the moon forward a few nights, and I stopped on October the 2nd, only because I wanted to show you. Put this on your calendars, October the 2nd. Check where the moon and Mars are right now. They are going to ride through the sky all night long together until they set, and it's going to be kind of fun. So put that on your calendar. But to sum up our point, the moon's apparent motion is from east to west. But when we remove the commonly sensed apparent motion, we can discern that the actual orbit path of the moon is from west to east. So I'm going to go back to our PowerPoint show now. It's fun to see how our senses can trick us when we're not looking at all the facts. Here's another commonly shared observation that most folks would easily agree with. Wouldn't you agree that the moon creates a lot of light, especially during the full moon? Well, the statement is commonsensically true. It's just not factually true. The moon doesn't create any light of its own. Stars generate light as a byproduct of nuclear fusion. Planets and moons reflect the starlight. By themselves, they make no light at all. Astronomers use the word albedo to describe how much light an object reflects. Here's a surprising fact about the moon's albedo. As reflectors go, the moon isn't that great. It reflects less than 12% of the sun's light. That great expanse of a full white moon that we see was actually a pretty dullish gray color when the astronauts got an eagle eye view. Well, the moon reflects the sun's light, and we call this reflected light moonlight. Facts like this are easy to shed light on. Speaking of shedding light, our next slide presents a fact that sheds a lot of light, but does not seem commonsensical at all. Here's an image of the sun drenching, shining on the earth. You look at that shining on the earth. Familiar, easy to understand. When one side of the earth turns away from the sun, the other side faces the moon. So sure, one half of the earth is always bathed in sunlight. But what about the moon? The image shows that the sun shines all the time on half of the moon's surface too, except for lunar eclipses, of course. Well, what the heck, is this some kind of a trick slide? The moon we see is not half illuminated every night. We see different parts of the moon illuminated throughout the month. This image challenges our commonly sensed perception of the moon's phases, but it is correct. Half the moon is always drenched in sunlight. This is possible because the moon's orbit around the Earth is not in line with Earth's orbit around the sun, as you can see in this little graphic here. It's tilted about 5 degrees. That's why it's possible. But we're going to return to this thought just a little bit later, because right now, as I look at the first image, I've got more questions. For example, is one side of the moon perpetually dark? Or does the moon rotate on its axis? Does the moon rotate on its axis? Let's start with that one. You may have heard this argument. We only see one side of the moon, and that means the moon does not rotate on its axis. Well, the first part is true. We do only see one side of the moon. Only astronauts and lunar orbiters have ever seen or photographed the backside of the moon. In case you've never seen a picture of the far side, here's a NASA photo so you can compare the near side and the far side for yourself. On the left, large dark areas called maria are prominent on the side we see, along with numerous craters. But on the far side, craters are the predominant feature, with very few dark maria. It's easy to agree that except for pictures like this, we never see the other side of the moon. We only see the near side of the moon. Well, oddly enough, the fact that we only see one side of the moon is what proves that the moon does rotate on its axis. And here's a quick way that you could prove it to yourself. All you need for this experiment is a round object, like a ball, to simulate the moon. To prepare for the experiment, draw your best smiley face on one side of the ball. That's it, we're ready to test. Imagine that you are standing in the middle of the picture at the blue ball, Earth. The smiley face is the moon. Hold the ball at arm's length so the smiley face is facing you, and keep it that way, just like the one side of the moon always faces the Earth. Study the sunlight for just a moment. You can imagine that the far side of the moon is drenched in light. You just can't see all that light because it's on the far side. Now turn your head and your body 1/4 of a turn to the left, like this. You are now looking to the east, and the smiley face is now looking to the west. The only way the smiley face could change from facing one direction to another is if the ball turned. The ball rotated 1/4 of a circle. If you turn to the left 3 more times, you will have made a complete circle and would be right back where you started. The ball would have made 1 complete turn as well. So the motion of the moon is just like the motion of the ball. During the time it takes to complete 1 orbit, the moon turns on its axis 1 time. So this simple experiment helped answer our first question. Does the moon rotate on its axis? Yes. It takes nearly a month, but yes. Let's continue this same experiment to unmask a related myth, that one side of the moon is perpetually in darkness. Continuing from our first quarter turn when we were facing due east, arm fully extended, turn 1 more quarter turn to the left. Now the near side of the moon is facing the sun, drenched in sunlight. But when we began our experiment, the far side of the moon was facing the sun, and it was drenched in sunlight. So I think this answers our question and puts another myth to rest. There is no perpetually dark side of the moon. Let me share a few other odd facts about the moon that maybe you haven't heard before. For instance, the moon is not a perfectly round orb like we see when we gaze at the full moon that's so beautiful. It actually has a touch of an egg shape with the larger end bulging earthward. And the crust of the far side of the moon, it's thicker than the crust of the near side, twice as thick. The thicker crust may be the reason why the far side has so many visible craters still. The far side craters were not filled in by the lava that more easily erupted through the thinner crust of the near side. Anyway, if someone tells you that there are no craters on the back side of the moon, you can say with authority that that is just a myth. Well, I think that we are ready to tackle the big question. We're going back to that fact where we talked about the moon being half drenched in sunlight all the time. So how does that reconcile with our sensation of the phases of the moon? Well, as they say, a picture is worth 1,000 words, and NASA's Space Visualization Team has put together an animation that helps explain these two apparently conflicting experiences. While you watch this 6-second excerpt, focus your attention on the left panel. It contrasts the speed of the Earth's rotation on its axis with the speed of the moon's orbit. Let's watch this animation together, but don't blink. It is quick. Wow. Could you count the number of turns that the Earth made during the moon's orbit? No way. But I'll vouch that while the moon turns on its axis just 1 time and orbits the Earth just 1 time, Earth has turned on its axis 27 1/3 times. Well, here's the takeaway. From Earth, we get 27 1/3 different angular views of the moon's reflected light while the moon completes 1 orbit. So I've snapped 4 still shots from the animation to highlight the 4 major phases of the moon. As we look at each slide, you can look on the left side and you can see that let me see if I get my mouse there, that the moon is always half lit, and that's about as much as this is going to show us, but the moon is always half lit. Look there to see where the moon is at, and look on the right-hand side, and we'll see what we see when we look at the moon from Earth. So in this first slide, I'd like you to notice that the sun and the moon and the Earth are no longer quite lined up. In this first slide, the moon is just breaking ranks, starting to leave that lineup. And half of the moon is basking in sunshine, as you can see, but look at this acute angle from the sun to the Earth to the moon. Very acute angle. So from this acute angle, all we can see is a fine crescent shape beginning to be visible. But after 1/4 of the orbit, Earth sees the moon at a 90-degree angle. Look at that. Half of the moon is still drenched in sunshine, and we see half of that sunlit side, the eastern half. And that's what you see in this picture over here. We're seeing the eastern half. We call it a quarter moon because that's how much progress the moon has made so far, 1/4 of an orbit. As on the other slides, half the moon is still drenched in sunshine, but now with half of the orbit complete, we finally see this fully lit side of the moon, and we call it the full moon. In our next photo, the moon has now completed 3/4 of its orbit. Again, Earth sees the moon at a 90-degree angle, which we can see here. Only this time, we're seeing the western half. In the first quarter, we saw the eastern half of the sunlit moon, and now we're seeing the opposite side. So the choreography of all of this to me is magnificent. The moon rotates on its axis, completes one orbit, ends up right where it started out 27 1/3 days earlier, month after month, year after year, showing us just one side all the while. In conclusion, the moon is always bathed in sunlight. Our view of its reflected surface changes throughout the moon's orbit, and we call our view of this reflected light phases of the moon. I hope you enjoyed the NASA animation as much as I did. I think it's fun, and I think it's informative. Well, speaking of fun things, have you ever heard this saying? The moon is made of green cheese. This saying was uttered long before it was recorded in writing in the early 1500s, and it's been repeated ever since. There are literally hundreds of children's books from around the world that repeat this or a similar myth. The saying, of course, is facetious and is associated with gullible folktale characters whose lack of acumen or perhaps greediness led them to do foolish things, such as the wolf, who was told by the fox that the reflection of the moon in the pond was a wheel of green cheese. The wise fox told the greedy wolf, "Drink all the water in the pond. That way you'll have the whole wheel of cheese for yourself." Well, as you might imagine, the adventure did not turn out well for the dull-witted wolf, and the clever fox lived to see another moon. Even NASA gets in on the green cheese fun. If you look online for the astronomy picture of the day from April 1st on 2002, it will lead you to NASA's April Fool's Day spoof, which confirms conclusively that the moon is indeed made of green cheese. We'll end our presentation shortly with a quick recap of some of the fun facts that we've shared, and then we'd like to have you look with us at some beautiful pictures of the moon. And after the pictures, we'll see if there are any open questions that are left over from the chat window. So to recap tonight's De-Myth-tefied misconceptions, the moon's orbital path is from west to east. It takes 27 1/3 days for the moon to complete this orbit and the same time to rotate once on its axis. Our moon and all solar system objects reflect but do not create light. The moon is a big reflector, and the surface area of reflected light makes it look really bright. Thank goodness it only reflects 12% of that sun's light. Well, except for lunar eclipses, the sun always shines on half of the moon's surface. Our earthbound view of the orbiting moon causes us to see the reflected light as phases. We do only see one side of the moon from Earth, and it's always the same side, and there is no perpetually dark side of the moon. The moon isn't really round, it's a bit egg-shaped, with the larger end facing Earth, and the crust on the far side is twice as thick as the crust on the near side. The far side is predominantly cratered. It does not have large maria that we see on the near side of the moon. And finally, the moon is not made of green cheese. Ha! It's made of Swiss cheese. Just kidding. Well, we're going to end this short presentation by sharing a brief but awe-inspiring video of LRO, which stands for Lunar Reconnaissance Orbiter. Photographs put together by NASA's Space Visualization Studios, SVS. We're going to see the eastern sunrise over the moon's basins, maria, craters, and mountains. We'll see shadows advancing across crater floors, shadows of central peaks, bright crater rims. It'll be followed by the western sunrise that happens after a full moon, when the shadows change direction as the moon's orbit returns towards the sun. After the short video, we'll try to answer any questions left over from chat window questions. So please enjoy this video with me. The sun's now rising over the eastern limb of the moon, revealing the first round dark patch of the Sea of Crisis, Mare Crisium. The waxing crescent grows. The terminator, the line between dark and light, advances about 10 miles an hour and reveals 3 mid-moon craters that show us the progression over time. The lowest one was the first of the 3, then the second, and then the newest one on top, Theophilus. Now approaching the Sea of Serenity, from the Sea of Serenity, I should say. The sun rises over the Middle Caucasus Mountains in the southern half of the mountains and casts shadows that lead us to the Sea of Showers, the Mare Imbrium. Can you see the shadows of the mountains? Just south of the Carpathian Mountains, the Copernicus crater at sunrise. Bright rays of ejecta surround the crater. Magnificent central peaks are rising. The precipice, its crest, are the steepest on the moon. North and west of Copernicus, the Aristarchus Plateau at sunrise. There's Aristarchus crater. Watch now as the prominent rills emerge in the sunlight. These are faults and tunnels where lava once formed. Next up, the magnificent Orientale Basin on the western limb of the moon. Note the concentric rings surrounding this massive impact site. Now on the far side of the moon near the South Pole, another large basin, Schrödinger Basin. Again, we see the collapsed lava tubes. The highly cratered lunar far side. Now to the North Pole, the lunar North Pole. Notice the shadows now going from your left to the right. Moon at last quarter. The sun is left of the moon and the shadows are reversed. Soon we'll see this on Theophilus, Cyrillus, and Katharina, the same 3 craters we saw moments ago in the beginning of the sun. Crater rim now advances to the right. back to Mare Imbrium, the Apennine and Caucasus Mountains, casting their long shadows now towards the east. Perhaps everyone's favorite Copernicus crater, and the bright rays of Kepler crater to its left. Just northwest of Copernicus, Aristarchus again. The interior of this crater is the brightest feature of the moon. Waning crescent moon. I hope you enjoyed that video. To me, it's thrilling. It's just beautiful. And when I look through my telescope, I have to tell you the truth, I see much of that same stuff, and it is just amazing to see the changes from one night to the next. But for now, that's it. I'll leave a few fun facts showing on the slide here, and I'll ask Brian if we do have any questions from the chat window that we should try to answer. Brian, did we get any questions that are needing answering?
Yes, we have a question from Dave. He says, well, it's actually an interesting observation. Google's moon map turns into green cheese if you zoom in too far.
I did not know that. It's
I did
fun.
not know that. I'm going to give that a test. But I have a couple questions that your discussion has spurred in me, because I was just last night I was doing my live picture taking from the desert, and I showed a picture of the moon, and I showed those Maria that you pointed out, which you said they were lava flows, right?
Right.
And that the backside of the moon we don't see doesn't have any of these Maria.
Not many, just a couple, yeah.
And it's attributed, you said, to the crust being thinner in the front, and so it spills through easier.
Yes, I think that's correct.
I always assumed, because I didn't study it, that the gravity of the Earth was kind of pulling that lava this way versus the backside.
Yes, I've heard the same explanation as well. And
Okay.
part of the reason why the crust would be thinner, because it's pulling the lava. At the time when it was liquid, earlier in its formation, 4 billion years ago or whatever it was.
And I heard you mention that you like to look through your telescope at the moon.
Yeah, yeah.
So you're an observer. What's your opinion of the moon overall?
Well, I heard you say your opinion last night. What a bummer for fellows like you who are such accomplished deep sky astrophotographers. And so I do have mixed emotions, I must confess. But I've decided to make the most of it since it's here so often, rather than, as they say, curse the light and curse the darkness, enjoy the light, or however that saying used to go. So I've decided that I should take advantage of it, enjoy it while it's here, see what I can see, and then after it's gone, enjoy what I can see later as well.
Yeah. Yep, good answer. We have another question that has come in from the audience. Amanda asks, did you say there was a brightest feature of the moon?
The crater Aristarchus is thought to be the most reflective surface of the moon. So that would be if you were looking at Copernicus. Gee, I wish I had thought to put a map of the moon on the slide here. But if we were looking at the Mare Imbrium, Copernicus just below it, and then to the left would be Kepler, which is also quite rayed and very attractive. And just to the northwest of those guys is Aristarchus crater. And as you look, it just smacks you in the eye. It's so bright. There's another one
Is
on
it the bottom or is it the rim?
no, it's not on the rim. No, no, it's not on the rim. Um, Gee, I feel silly. I wish I would have had the whole shape of the moon to share with you. Don't have that. But there's a similar small crater called Proclus,
Yeah.
just 10 miles wide. It's a really small little guy over there on Mare Crisium, that first one we saw when we were looking at the eastern, that first round mare or basin that came up as we started the show. And there's a little 10-mile wide crater that is called Proclus. That is a real bugger. It is really bright too. So between those two, those are the ones that always catch my eye, as Aristarchus over here on the left and Proclus over on the right.
All right, we got another question. Tom asks, when did you first become interested in astronomy?
Oh my goodness. Always had a inner inkling. I felt so silly. The moon is such a large part of our world as we don't know it. And I felt so disassociated from things. I thought, my goodness, people, in olden times relied so heavily on the moon. And today, with everything lit up, we're just so totally out of touch. And I felt like I didn't want to be out of touch anymore. So I started looking. And that's kind of how I got interested.
Okay. Richard points out that the October issue of Astronomy magazine must have something on the moon.
Excellent point. The moon is going to experience two full moons in the month of October, on October 1st, and very graciously on October 31st on Halloween. So we're going to
Wow.
get blue moon, which means just a way of saying two full moons in one calendar month. So October will be special in that regard for sure, of course. What I think everybody's looking forward to in October is, and there's no necessary reason to wait until October to look, but to look at Mars, which is going to, of course, be at its closest to us and look its biggest and brightest, what I think on October the 13th. But like I say, that almost conjunction, near conjunction on October the 2nd of Mars and the moon, that's going to be fun to see too. And it's going to travel that way together all throughout the night. So that should be pretty cool. Pretty cool.
I got that on my calendar. Definitely going to take a picture of that. We got two people, it seems like, they asked the same question. Joanne and Amanda both asks, what makes Aristarchus so bright? What is causing this bright white?
Part of the reason is it's one of the newest craters on the moon, and so it hasn't had the opportunity for other subsequent collisions of the moon to throw their ejecta down into the crater, and it takes maybe 1,000,000 years or so to dull from other activity. That's what happened to a lot of the other craters. As the subsequent craters come along, get hit by asteroids and meteors, the ejecta goes out and it dulls, if you will, by covering up with the regolith. It covers up the shiny surface. So that tremendous heat from the asteroid or the meteor slamming into the moon at thousands of miles per second actually melts just about everything and causes kind of like a glaze almost, if you will. And the reflectivity of that has not been spoiled because it's relatively new. And also just the angle that it hit, I think, has also got a lot to do with it, that particular crater kind of shines right back at us. Does that sound reasonable?
Yeah, that's why it's so bright. Yeah, it's fresh.
Yeah.
Yep, yep, totally got that. And I think we've got time for one final one that has come in from M Bar Era. Where's the boy sleeping or fishing from the moon?
Where is it? That's not one of the things that I've seen. A lot of people will see rabbits on the moon or a man on the moon, but I've not seen the boy fishing on the moon. So, have you seen that one, Brian?
No, no. I don't think I've ever even heard of it before.
No.
But I'm sure if you Google it, somebody has
Somebody's
superimposed the drawing right over the real moon. But
Well,
definitely the rabbit, the bunny in the moon. I've
yeah.
seen that.
Well, that's what's kind of fun about looking at the stars is, I mean, there's just no right way to do it. You can look at the stars, and there are some traditional asterisms up there, patterns that we see, like the Big Dipper, that everybody says, "Oh, I can see the Big Dipper," and so we can talk to one another and share stories or whatever. But there's no wrong way. You can see what you do see. Whatever helps you to enjoy the night sky. There's no wrong way to do it.
Yeah, well said. Well, we'll leave it there, and thank you, John, for a great presentation on the moon. And I want to tell the folks out there that please take a look at the survey and tell us what you think. It's on the website, right at the top, and you can click on it and take the survey. Tell us what you thought, and be sure to have a lot of fun with some of the other presentations that we'll be going till midnight tonight. So tune into as many as you can. So thank you, everybody, and good night. Good night for now.
Okay, thanks a lot.
All right, we're good. Um, I saw a total of 66 people were watching.
So we're not live anymore then, right?
There, I just clicked end.
Yeah. Yeah.
Yeah.